Welcome to this video tutorial on the National Guidance for Plastic Pollution, Hotspotting and Shaping Action. This video is going to be about GIS, so producing these nice maps where you have kind of a detailed analysis, almost a kilometer by kilometer of what happens in the country, where is the waste generated, where is the waste mismanaged, and where is the leakage coming from. So you find it in kind of down at the end, and it's an optional step because we've seen that we can compute the leakage rate just by using the leakage up for the country just by using a 10% release rate. And what the geographical modeling allows us to do is to refine that 10% and additionally to have an idea of what are the areas that are more critical. The thing is that in order to do these kind of maps, you need to be knowledgeable in GIS and in Python. So these are maybe two tools where not everybody is comfortable with. But GIS is this kind of tool. Let me show you what is it opened. And then Python, is like a coding language. So if you're interested in this subject and you in this topic and you want to give it a try and map within your country the situation, then I'd suggest that you go to the website where the modules are. You go down to module T5, you download the module, and module T5 really guides you step by step on how to do things. And you see there's going to be first a data collection, because if you want to visualize things at a more refined geographical level, you need to collect data by region, kind of, and say, in this region or this area, the collection rate is this much, and so on and so forth. Then you can use the GIS modeler. Finally, you have to import some of the output of the model in Python to run the leakage assessment. And then, well, this is more a step for you to keep track of what were the modeling assumptions in terms of data collection. And then you can just plot the result in a table in addition to the maps that you generated. And if you scroll down, and I think the most interesting part is probably how to use the GIS model, but it really tells you what to do step by step. So you go on this website and you download the polygon profile of the country, and then you download population data, where the watersheds are, because we said that the water runoff is important in determining where the intensity of the leakage. So the runoff data links to watershed, and then you have where the rivers are, administrative boundary, urban, like in case you want to make a distinction between urban and rural areas, and then coastline is something that you need to generate yourself from the country polygon. So once you load everything, this is what it looks like, for example, in the case of Thailand, of Vietnam. And the modeler is the tool T5.2. And you see that it kind of tells you, it's going to take the country, it's going to convert the polygons to line. It takes all the input that we created, and then it does various steps in order to compute what's the leakage from each kilometer square of area. And then it tells you that different countries use different geographical reference systems. So you need to check a few places in the model where you need to change the geographical region. And finally, you can click on run and you can select the different input files that you loaded. You click run in the processing modeler, and that's it. And then you have your output file created, and your output file at that point needs to be imported in Python. And this is what is gonna look like in Python. And you see, I mean, here I think it's just a small portion of it, but you're gonna have a lot of points, because it tracks kilometer square by kilometer square. And then in Python, you need to input the file path, and running Python is gonna produce the information about the leakage, and this is gonna be in 1,000 tons, and that value you can use it to replace the one that we estimated with the 10% release rate in the toolkit 3.2. And finally, you're gonna have these sorts of maps created, but this is like an extra step that you need to do. You need to import different layers and visualize them one by one. And this, as I said, is more like to track the hypothesis that you've done. And tool B will be to have it written down, the different provinces, population, kind of all the data that you input in the code, but then also the leakage rates if you want, the leakage if you want. So I'm just gonna maybe show how it looks like, for example, this input data that we need to input. So for example, river, if you download it from the website that we saw earlier for Asia hydro rivers, here I'm talking this list of files that is required as input. So this is QGIS, and you're going to see a map is going to appear over there. You see those are all the rivers in Asia, and it's quite a heavy file. It's hard to distinguish the river, but if you zoom in, you should be able. You see there are like all these different rivers, and then population data are usually, so sorry, if the watersheds are here, oops, I uploaded it twice, and then countries would be over there. So you're gonna have all the world countries, but then you have to select your country of interest. In this case, it would be Vietnam. You select it, and then you go over there, and then you say export, save selected feature. So you save only Vietnam. And for example, the graphical modeler, instead, you find it here. So you go to graphical modeler, and then you have to find it in the tools. In my case, it's gonna be over here. You see, this is the model that you saw the screenshot of earlier on. And then once you upload all the files, you can go to run, and here you have to select the loaded. You see now we only, it shows you the layers that you have already loaded, and you can choose from it. So for example, country we don't have, but Idle River would be this one, and then watershed is this one, but the rest we haven't loaded yet. And then once you're done, you click run. One thing that you need to be careful of is this entry. You need to make sure that it goes to an appropriate path, and you need to save it as save to geo package. This is important. It needs to be saved to geo package, because otherwise it kind of maps every kilometer. The geo package means that all of these kilometer squares are assigned to a location, and when you map it back, when you re-import it in GIS after treating it in Python, it's gonna remember where they are. So you have to save it to geo package in a location in your computer, and not in. Here's the path, the local path in your computer. And once you produce the results, then the other tool is the Python tool, and that is so the Python tool is the tool T5.3, and you need to open it with the Python kind of reader. And I'm gonna use Jupyter just to show you how it looks like. But I'd say that unlike the Python tool that we used for ComTrade, that was kind of pretty straightforward. You just need to input some path. It would be good to actually have an understanding of Python to be able to read this tool and to understand what happens, because most likely you will have to edit some of it to adapt it to your needs. And then maybe one point that could be of interest. So this is the tool, and you see you need to say where is your waste folder, the waste file. So the file with the information regarding the waste, and then this is going to be the file with the geographical and hydrological data per kilometer square that we generated, and this is the output file. So how you want to call the output, the population files. So there are quite a few files that you need to load, and then you see you're gonna have to go through quite a few steps in order to generate the leakage. And once you have that, you re-import it back in GIS, and then you can create these maps that we were talking about. Yes, one point that I wanted to make is that if you have a big country, like if you were to do South Africa or China, most likely, or Russia or Australia, most likely the modeler will be too slow to run, and the computer, your local laptop, will not be powerful enough because it treats the information per kilometer square. So the bigger the country, the most complicated it's going to be for it to run. So one thing that I could suggest is to do it region by region. So you, one of the files that you are advised to download is is the administrative boundary file. Yeah, administrative boundaries. So for example, I think I have it, I mean, I definitely have it for the case of Vietnam, for instance. Is enough. And you can have vector file or raster file or delimited text is CSV files. So when you import from Python, it's going to be a CSV file. So you see over here, you have a subdivision of Vietnam in different regions. So one thing that you could do is to say that you only want to work with this region. So you call this one, you call it your country, instead of calling the whole of Vietnam your country. And I would suggest to do that if you need to do a big country, because it's definitely going to be easier for it to run. But then probably you'll have to adapt a bit the modeler, especially in the areas that don't have access to the sea. And that's it for the modeling of the regional hotspots.